Hi, everyone. In the previous session, we explained the definition, or we gave the definition of the compound interest and the difference between the compound interest and the simple interest. In this part, we are going to give the formula that is to ease our work in the evaluation of the compound interest. So normally, easy to know that the compound interest after our work in the previous session, we can remark clearly if we have a deep vision that the formula can be the formula that can be used to calculate the compound interest is given by the following expression: big A equal to big P factor 1 plus big R power n. We mean by A the total amount of investment after the compounding period, and P is the original principal that we invest in the beginning of the first year of investment. The big R is the small r, the rate of investment, the percent interest rate per compounding period divided by 100. So big R equal to small r over 100, and n is the compounding period, is the number of the compounding period. We should be aware of using the same unit of time, compounding period, year. So we should use year, month, quarterly of year, and so on. So I will give you some hint in the next session and the next slides and idea. So first of all, we want to explain the formula and how to use directly and how to apply the formula to calculate the amount of investment and the amount of interest earned over this period. Okay, first of all, we have a 10,000 gross. So normally this is the big P for us. If investment for 8 years, so is the N. The number of compounding period is given in years, 8 years, and per annum. We should ensure that we are using the same unit, years per annum. So normally are the same, very similar, convenient. So we complete to use the following, we complete to calculate. So this is the N and this is the small r. So the big R is 4.5 divided by 100. So the big R equal to 0.045. We can easily remark that this factor and the term inside give us the constant multiplier 1.045, the constant multiplier that we used and we explained how to use it in the previous session. So we substitute the big P by 10,000, the big R with 0.045, the small n with 8 to obtain finally $14,221.01. And the amount of interest earned over this period, so we calculate the difference between the two values to obtain 4,221, okay, dollars. Then after that, it's easy to complete. The following exercises are very similar. Okay, so we should be very careful when reading the given and the information, and to accord to the information to the convenient value or the convenient letter in the formula. So 6,000 refers to the principal, 5 years to the small n, 3% per annum to the small r, big R equal to 3 over 100, and so on. So easy to calculate it. But sometimes they give us different information or confused information. For example, complete the following using the compound interest formula to calculate the amount to which 10,000 grows if it is invested for 3 years. 12% per annum interest compounded monthly. So monthly so each month the principal is changeable. It's changeable. So at the end of each month we have a new interest we added to the principal. So the next month we have a new principal. Oh, good. So normally the small r, okay, if the small r per annum equal to 12%, so per month 12 divided by 12, so 1%, the small r per month is 1%. So normally if we count the rate in months, so we should count the compounding period by month. So 3 years equal each year is 12 months. So 3 years, 3 by 12 equal to 36 months as a whole. Okay, good. So we convert all both rate and compounding period into months, and we put all together in the same formula that we have to obtain the amount. If we compound the interest monthly, after 3 years of investment, we will obtain 14,307.69 from $10,000. Quarterly, if the interest is compounded quarterly, okay, quarterly, so each quarter of a year. So normally we have a 4 quarter in a year. So normally 12% per annum, we have a 4 in 1 annum. So we divide the 12 by 4 to obtain 3% after each quarter. Okay, per quarter. And we know that if we convert into quarter the rate of investment, so we should convert also the compounding period into quarters. So normally in each year we have a 4, so 3 years by 4 we have a 12 quarters along 3 years, in 3 years. So at this level we can substitute all the values, all the terms by its corresponding values. We're using the same units. Okay, so we will obtain 14,257.61 and so on, and the same for 6 months we will obtain 14,185.19 dollars. We can remark clearly that if we compound the interest or we compound our amount of investment each month, we will obtain, after the compounding period and the investment period, will obtain a amount bigger and larger than if we compound it per quarter of year, and larger than, and so on. So it increases if the period decreases. So normally we can say that the principal grows much more rapidly when the same rate of interest is compounded by per shorter period. Okay, so the principal or the amount of investment at the end of the compounding period increases rapidly when the same rate is compounded of interest per shorter period decreases when the period of investment of compounding decreases. So for sure, if they ask us about which of the following investment will earn the greatest amount of interest, so normally we have a yearly, 6 monthly, quarterly, monthly, simple interest. We can first of all cancel this choice because the simple interest doesn't work here. Is always remains always the lowest Okay, so normally they are asking about the greatest, and as I said before, the greatest is for when the interest is compounded for the shorter period, the shorter between yearly, 6 monthly, quarterly, monthly is monthly. So D is the correct answer. Also for the same idea for when we have a days, so we should also calculate the rate, recalculate the rate per annum in days, because the 16% per annum, so per days is 16 divided by 365 percent. So percent again, we divided by 100 to obtain big R. So big R is all these terms together. Okay, and we put also 27 as compounding period in days and so on. So these are the most important information in this lecture. Thank you for listening and have a nice day.